we have the enthalpy of neutralization, right? So what is enthalpy of neutralization means? See, what do you mean by neutralization? We already know that, when acid combines with base to form salt and water. That's what we have been doing neutralization as, right? So now there's a certain limit. How do I define the amount of energy? Understand neutralization is always an exothermic process. Whenever you mix an acid with a base, right? Whenever you mix an acid with a base, the energy is always released, right? The energy is always released. So you have to understand that the amount of energy released when 1 gram equivalent. Now there's a term here. What is gram equivalent? When 1 gram equivalent of heat of acid combines with 1 gram equivalent of a base, with 1 gram equivalent of a base. You understand my point? So this is the definition. But when it comes to, what is 1 gram equivalent of an acid and what is 1 gram equivalent of a base, I would always tell you an easy way out. The easy way out is always remember that whenever 1 mole of H plus combines with 1 mole of OH negative,
Right.
right, then how much amount of energy is being produced is actually the heat of neutralization. That's how you should, I think, understand. You understand? So now, for example, if I tell you what is 1 gram equivalent, I'll tell you. So, for example, you see calcium hydroxide. So, calcium hydroxide is like 40. What is the mass of calcium hydroxide? 40 grams. And the mass of hydroxide would be 16 plus 1, 17 times 2, 34. So, for me, it would be 74 grams, isn't it? So, I know that, 74 grams of calcium hydroxide would actually give me 2 moles of OH negative. But how many moles of OH negative do you think I need? I need only one. So that mass of a substance which gives me 1 mole of OH is actually called as a gram equivalent. You understand?
Yeah.
So
Right.
2 moles of OH I am getting from 74 moles of CaOH whole twice. Yes or no? 74 moles of COH whole twice. 2 moles of OH negative. You understand? But the point is, that I need only 1 mole of OH negative. So the 1 mole of OH negative I will be getting from how much? 74 over 2 grams of CaOH whole twice. And how much is that mass? That comes out to be 2 times 37. So 37 grams. So a packet, which has 37 grams of calcium hydroxide in it, would in reality be called as my 1 gram equivalent. So just like
Okay.
1 mole is a packet, right? Similarly, 1 gram equivalent is also a packet. So how do I define 1 gram equivalent of a base? That, a packet of base which consists of that much mass, which if it gives me out only 1 mole of OH negative. And 1 gram equivalent of a base means that grams of a base, that grams of an acid, which can give me 1 mole of H plus ions. You understand? So this packet is called as a gram equivalent. So what am I saying? That, for example, if I'm saying HCl. So HCl, what is the mass of HCl? HCl mass is molar mass is 1 gram for H plus and 35.5 grams for Cl. So it shall come out to be 36.5 grams, isn't it, for HCl? Yes or no?
Right.
So what do you mean by this particular part? What do you mean by 36.5 grams HCl? You mean that, ma'am, if I put 36.5 grams of HCl in one packet, So basically, I have deposited 1 mole of HCl into it, and this 1 mole of HCl would also give me 1 mole of H plus, because obviously one molecule has only one H plus. But in the previous example, I had this packet which consisted of 74 grams of calcium hydroxide, which meant what? Which meant that, we had 1 mole of calcium hydroxide. But that 1 mole of calcium hydroxide was actually giving me 2 moles of OH negative. So this one packet was actually what? This one packet was actually 1 mole of the molecule. But I needed 1 gram equivalent. What is 1 gram equivalent? That packet which gives me 1 mole OH negative. So that means I should have deposited 37 grams and 37 grams into one packet each. So that this also gives me, so this is basically half mole of calcium hydroxide. And this is also half mole of calcium hydroxide. But in reality, both these packets are giving me 1 mole of OH negative each. Are you understanding? Both
Right.
these
Yeah.
packets are giving me. So can I say 1 mole packet of the calcium hydroxide is actually giving me 2 gram equivalents of calcium hydroxide? Are you getting the difference? The mole is of the molecule, which could give me any number of OH negative, doesn't matter. But if I say 1 gram equivalent, I require that packet to give me just 1 mole of OH negative or 1 mole of H plus, depending upon
Right.
whatever is the case, you know, whatever is the case.
Yeah.
If it is an acid, so I would be looking for the gram equivalent for an acid. So I would be looking for that packet of an acid, which would give me 1 mole of H plus. So now,
Okay.
so now,
Right.
now you understand. Like for example, if I take one packet, which consists of 37 grams of calcium hydroxide, and if I have another packet which has 35.5 grams of HCl, so you understand that the masses definitely are different. But I know for sure that this 37 grams of calcium hydroxide would be able to give me 1 mole of OH negative. And this 35.5 grams of HCl, because that's the molar mass, and 1 mole of HCl can give me 1 mole H plus. Yes or no? So
Yes.
it is going to form 1 mole water. And when water is formed after the combination of H plus and OH negative, in reality, this is what we call as neutralization. In reality, this is what we call as neutralization. Are you understanding my point? So, what is neutralization? When one normal definition for small kids is like when acid combines with base to form acid, salt, and water. But in reality, neutralization means when 1 gram equivalent of a base. So 1 gram equivalent is nothing, it's just a name. Okay, don't consider that it is something 1 gram. No, no, no. It is like a packet,
Okay.
like the dozen. The dozen means 12. Score means
Right.
20, right? So it's sort of that kind of group name. So it is giving me 1 gram equivalent of acid when it combines with 1 gram equivalent of a base. Okay, 1 gram equivalent of a base. Yes or no?
Right.
Hmm? So this is the concept. So when I say that 1 gram equivalent of an acid combines with 1 gram equivalent of a base to form salt and 1 mole water, 1 mole water, because definitely I'll be getting OH negative 1 mole and 1 mole H plus. And when 1 mole of H plus combines with 1 mole of OH negative, I will be getting 1 mole of water. And the energy released at that time is 57.7 kilojoules per mole of water being formed. Are you understanding?
Yes.
So if I ask you that, how much energy is released for a given neutralization reaction, so I could give you any equation. I could say that, ALOH whole thrice is combining with what? Tell me. ALOH whole thrice is combining with what? It is combining with, let's suppose, H2SO4. So how do I
Okay.
frame the equation? This H2SO4 is actually going to break like this. So H plus and SO4 minus 2, isn't it? And AlOH whole thrice will break something like this: Al plus 3 and OH negative. So definitely the positive will combine with negative, and the positive shall combine with negative. So I will have what? I will have Al2SO4 whole thrice as the salt being formed, along with it the water. Because H plus shall combine with OH negative. That's my double displacement reaction, isn't it?
Yes. Right.
But what exactly would it mean? Tell me. But what exactly would it mean? Just tell me. It would mean, if I balance the equation, I would be needing 6 H2O being formed, 2 here, right? And 3 here. So now you have a look at the equation. Why am I doing that? Because Al requirement was 2, because Al2 was being formed. So I would put in a 2 right here. And SO4 was thrice, so I would put a 3 here to make SO4 3. Then you see OH becomes 3 times 2, 6. And H also becomes 3 times 2, 6. So when I say 6H plus combines with 6OH negative, I will have
Yeah.
6H2O being formed. I hope you're understanding my point.
Yes.
Any doubts in this?
No.
You understand? So when I have 2
Yes.
AlOH whole thrice to give me H2SO4, to give me Al2SO4 whole thrice plus 6H2O, how many moles of water is being formed? Definitely you know that, AlOH whole thrice is a base and H2SO4 is an acid. So, when they combine, what do you think we have? We have Al2SO4 being combining with 6 moles of water is being formed. I hope you're understanding. So for every 1 mole, what have we learned? That when every 1 mole of water is formed during neutralization, 57.7 kilojoules of heat per mole of water formed is released. So can you not tell me the delta H reaction for this particular reaction? So delta H heat for this particular reaction shall be what? 6 times 57.7. And that shall be my delta H reaction. And that shall be how much? 6 times 7, 42, 4. 6 times 7, 42, 46, 4. 6 times 5, 30, 34. So 340, it would be 30, 346.2. Understood or not?
Yes.
Any doubts in this?
No.
So this would be the heat of this particular reaction. So the amount of heat released during the neutralization reaction is actually what? Is actually what? You tell me. It is going to be 6 times H2O, right? It is dependent upon the amount of water formed during a neutralization reaction. Understood or not?
Yes.
All right. So this is how we sort of have a particular, the neutralization reaction energy calculations. So now if I ask you to calculate the energy required or produced during this neutralization, just do this for one for me. If I give you this equation, if I give you H2SO4 plus BaOH whole twice, and I want you to calculate the amount of, you know, energy released during this particular reaction. What do you think would that be? So if you break it down, it becomes H plus and SO4 minus 2. Because obviously, the 2 here is coming from the heads of SO4. And here this
Right.
2 is coming from the heads of barium. Because the valency
Yeah.
of barium is plus 2. So I would be breaking
Yeah.
this down into Ba plus 2 and OH
Yeah.
minus 1. So I would have positive going into negative and positive going into negative. So I would have
Right.
BaSO4 as the salt
Yeah.
being formed,
And then what?
and I have water.
Yeah.
Yes or no? Now you
Yes.
have to balance the equation first and then tell me my answer, that what is the heat of reaction, and you know in your mind that it is a neutralization reaction, definitely, because H2SO4 is sulfuric acid, and anything which has OH, even if you do not know the name, though the name is barium hydroxide, but even if you do not know the name, for sure you know that it consists of what? Hydroxide. It consists of OH whole twice. Yes or no? So
Yes.
barium sulfate plus water, and I will have the salt and heat of reaction so formed. Yes or no?
Right.
So this is my salt. So I want you to tell me how much amount of heat is being produced in this reaction. Tell me. This is sulfuric acid. Exothermic process.
Yeah.
Neutralization is an exothermic process. Yes or no? Is an exothermic process. Yes or no?
Yes.
So 57.7 kilojoules of heat would be thereby produced for 1 mole water. How much water is being formed in the balanced equation 2? So the heat of this
Two.
neutralization reaction shall be minus 57.7 times 2.
Right.
So whatever that comes out to be 114 and 1.4. So 115.4 kilojoules energy is the energy for this particular reaction. Yes or no?
Right.
Okay. So this is the basic equation. Now, when you have equations, when you have the equation questions, you have to understand that you have to frame the equations also sometimes on your own, and then put them into the according to the question, and then you have to solve them. Understood or not?
Right. Okay.
Right?
Yeah.
The last heat, which is the heat of hydration. So today I will be able to complete all the heats of all the enthalpies. Tomorrow I will help tell you how to solve the Hess's law questions.
Okay.
So we
Right.
have enthalpy of hydration, last enthalpy, and I will check in if I'm not mistakenly, left anything. But as much as I know, I have been able to cover up every type of enthalpies. So it says
Right. Okay.
enthalpy of hydration. Now, what is enthalpy of hydration? Understand. Hydration means what? There are different types of hydration. See, an ion can also get undergo hydration, you know, and sometimes even the molecules also can undergo hydration. Like for example, if I say that you have copper sulfate salt. Now, this copper sulfate salt in reality, this is anhydrous salt. This is anhydrous salt. Anhydrous means dry, right? In Hindi, we call it a sukha. So it is totally an anhydrous salt with no, with no pinch of water in it. But when you have dissolved this in water for a long time, you allow it to dissolve in water for a long time, let it remain in water for a long time, and then you filter it out. So you see that
Right.
the copper sulfate molecules actually gain 5 molecules of water per molecule. Every molecule of copper sulfate will attract or sort of bond with 5 molecules of water. So this surrounding of a copper sulfate molecule of with water, and this is not a normal bond, right? This is actually a sort of coordinate bond, a very strong bond. And you know that whenever a bond is formed, energy is released. Energy is released. Are you
Right.
understanding my point? So whenever a bond is formed, energy is released. That's very, very important to understand. So that means what? That means what? That copper sulfate was alone, and now when you allow it to absorb some water, or when you allow it to, when you allow it to do what? Copper sulfate is like anhydrous salt, dry salt. But when you allow it to remain in water for a very long time, it becomes a hydrated salt. It becomes a hydrated salt. Understood or not?
Right.
And when it becomes an hydrated salt, that means some amount of energy is definitely released. So, enthalpy of hydration. Now, there is no hard and fast rule. Sometimes, we force a compound to become hydrated. So, then when we are forcing it, we are providing it energy to bond forcibly under pressure with the water. But sometimes, you simply put the salt in water, and it quickly absorbs water and it quickly bonds with water. Then what do we say? We say, the process is exothermic. So there is no hard and fast rule for the enthalpy of hydration. Generally, it is exothermic. It is assumed to be exothermic, and it is actually exothermic. But it can be endothermic sometimes. It can be endothermic sometimes. I hope you're understanding.
Yes.
You
Right.
understand? So this is the concept. It can be endothermic sometimes. So my point of concept here is that when we are talking about the enthalpy of hydration, so copper sulfate, when you're allowing the water to dissolve the salt, when you allow the water to, have the salt in it for a long time, it might quickly dissolve into it and absorb all the molecules of water around itself, and then some amount of energy is being released. And you have to understand, where is that energy coming from? Because of the new bonds that the water is forming with the copper sulfate. During that new bond formation, the energy shall be released. I hope you're understanding the concept. Yes or no?
Yes.
Yes or no? Similarly, I can give you an example of FeSO4. So this is ferrous sulfate. And you understand that, most of the anhydrous salts are white in color,
Right.
are white in color. But the moment it absorbs water, it becomes blue, like copper sulfate becomes blue. And now, when you put it in water for a long time, automatically it is going to become FeSO4 dot 7H2. And that is nothing. The common name is green vitriol, because the moment it absorbs water, you know, it is going to become green in color. It is going to become green in color. The actual name for this compound shall be ferrous sulfate heptahydrate.
Okay. Right.
Hepta means seven, right? Heptahydrate. Hydrate is when something combines with water. Similarly, it would be copper sulfate pentahydrate, isn't it? It shall be copper sulfate
Entire.
pentahydrate. So that's the
Right.
chemical name that we have. But you can also call it as blue vitriol, because of its color. So because of its color, you can also call it as blue vitriol. Yes or no?
Yes.
So in this example, heat is actually getting released because naturally they have the tendency to bond with the water. You understand?
Right.
And thereby, if you know the nature, if the forward reactions nature, so if I write down the backward reaction, definitely, you will be able to tell me that, ma'am, if you're writing CuSO4 dot 5H2O, so it is converting into copper sulfate and water is getting removed. So you can understand that, I will have to provide it heat, because only then that attached water will be evaporated. By providing heat only, this attached water shall be evaporated, isn't it?
Yep.
So that is the concept. That is the concept. Are you understanding my point or not?
Yes.
Right? This is the concept. So whenever we are talking about the enthalpy of hydration, right? Generally, and 99% for all those salts which are soluble, for all those salts which are soluble salts, it would be a exothermic process. It will be an exothermic process, right? But for all the salts which are sparingly soluble or insoluble, it would be an endothermic process.
Okay.
Yes,
Got it.
that is the concept.
Yeah.
Okay. So this is enthalpy of hydration. Now, based upon the enthalpy of hydration, there are different types of salts. There are different types of salts. So these words you will encounter while doing this chapter.
Okay. Right.
So the different types of salts is, number one salt is soluble, is everybody knows, which dissolves into water. Insoluble is which is not soluble in water. So obviously the insoluble salts would do what? When you take water and you add the salt into it, what do you think would happen? Just tell me. That salt will settle down at the bottom. So I will say
Right.
what? I will say that the salt is forming a precipitate. The salt is forming a precipitate. I hope you're understanding. Why? Because the salt is insoluble. It does not want to dissolve in water. So
Yeah.
thereby, for insoluble salts, the enthalpy of hydration would be what? It is not trying to even bond with water. So even if you want it to bond with water, you will have to provide a lot of energy from outside, so that it can hit the water molecule again and again and again, and then the bond could be formed.
Yes.
So different types of salts are, one salt would be the deliquescent salts. The deliquescent, deliquescent, the deliquescent salts. These are the salts like a normal common salt. What about the salt? The salt is that, if you place a bowl of salt, or a beaker containing that salt into atmosphere, and that our atmosphere has a lot of what? Our atmosphere has a lot of humidity into it, right? So when our atmosphere has humidity into it, so it is going to absorb all the water vapors from our atmosphere. I hope you're understanding. Yes or no?
Yes.
And deliquescent salts would mean atmosphere has lot of humidity. So even just, you place it in the atmosphere, the open atmosphere. So whatever the water vapors are there above it in the atmosphere, it is going
Yep.
to absorb all of those molecules into it. You understand? It is going to absorb all of those molecules into it. And when it is going to absorb all the molecules into it, I hope you're understanding that, these molecules, if water is being absorbed into it, the salt dissolves into the the salt dissolves into the atmospheric pressure, and into the atmospheric water vapor,
Right.
and finally converts into the liquid form. It's like normally when you mix, salt into water. So that's how it would be. So deliquescent salts are what? Deliquescent salts are those in which actually dissolve, which can absorb a lot of moisture. The better definition is which can absorb a moisture. So moisture absorbing salts. Moisture absorbing salts. And finally converting into liquid state are actually my deliquescent salts. Are you understanding?
Right.
And the other salts would be my hygroscopic salts. Hygroscopic salts. Now, what are hygroscopic salts? Hygroscopic salts are those salts, okay? Hygroscopic salts are those salts, which which absorb the moisture, but they do not change their state. If they're solid, they would remain solid. So when put into open atmosphere, yes or no? It would it would do what? When put into an open atmosphere, it would absorb the moisture but not change its state. But not change its state. You understand? But not change its state.
Right.
So, so such compounds are called as hygroscopic salts. For example, I'll tell you. For example, do you see those silicon tablets, silicon packets which we get in those bottles or tiffins or any cloth
Yes.
compound?
Hospital.
Yeah. What are
Yeah.
they? They are sort of there so that there is no smell developed in the bottles. There is no smell developed in the bottles, you can say, or there is no smell actually developed you know, in the clothes. So we add in those silicon packets. So that SiO2 is there in that. And SiO2 is actually silica. You understand? So silica is an example that no matter how much moisture it absorbs, right? It is not going to convert into the liquid state. It would maintain its state. So hygroscopic means what? Hygroscopic and deliquescent. And deliquescent. Both absorb moisture. Both absorb moisture, right? That's one thing common in them. But what
Right.
is the difference? Deliquescent becomes liquid after absorbing, liquidifies.
Okay.
And hygroscopic was solid and will remain solid. And remain solid. That's the difference. After absorbing moisture, the hygroscopic was solid and will remain solid. Deliquescent, after absorbing moisture, becomes from solid to liquid in the beaker itself, and it dissolves. See how much water absorption capacity it has. So definitely for the deliquescent salts, the heat of hydration would be very, very high because it has a very high tendency to bond with water. You understand my point,
Yeah.
right? So the kind of words if they give you, so they would say that there is a hygroscopic salt. So you understand that there is a possibility that the enthalpy of hydration would be positive because hygroscopic salts are not much soluble in water, and the deliquescent salts are soluble in water. So they are trying to tell you that delta H is negative because the bond is being formed. I hope you're understanding. Right, Shruti?
Yeah.
Okay. So that is the concept. Understood or not?
Yes.
Right.
Understood.
So I think that should be enough for today.